All right, now you guys are absolute experts at authentication, and I think it is time to move to the next module of this playlist. So we are done with authentication. I hope you guys feel pretty comfortable with that part of the app. And now we're gonna jump into the real bread and butter of Firebase and of this playlist, which is Firestore. So Firestore is the database that is in the Firebase console. This is basically, if you follow my channel, we've done things like we've done core data where we have a database on the app. This is very similar to that, except the database is actually on the server. And this makes our app, of course, much more scalable. Users can share data and all of that fun stuff of having an actual remote server. There are a ton of features and caveats and good things to know when dealing with how to create a database, how to manage your database. So this is going to be a multi-part video on Firestore. This video specific, we're not even gonna write any code. We're just gonna open up the console and just play around with kind of how we can set up data, how we can manipulate data, and we're gonna talk about some use cases in this video. I think by not writing code right now, it's going to make it a little more clear when we actually start to write code, what that code is actually going to do. So that's my hope. I'm pretty sure you will agree. So stick with me in this one because we're going to really talk through what we're going to start writing in the next 4 or 5 videos, and then we're going to go ahead and write it. This is one kind of nexus event though, that if you don't understand this video, and if you don't start watching the next 5 videos in order, you're probably going to get stuck or confused because a lot of the code in the next 5 videos, it's all connected because we're going to start building out one manager class, which we're using for all of these different features. We're going to cover essentially everything that you need to know with Firestore so that you can set up your own databases and hopefully not have questions by the end of this. All right, welcome back, everyone. We have made it through the authentication section of this course. We're going to now move forward to some of the other products in the Firebase SDK, specifically Firestore, which is probably maybe their flagship product. When people say that they are using Firebase, generally what that means is we're using Firebase as our backend database, which refers to either the Firestore database or the real-time database. Of course, you can use Firebase without using these, but the databases are kind of the first reason I think people use Firebase. So I'm only going to cover the Firestore database. I'm not going to do the real-time. Essentially, they function very differently, but you can use either of them for your application. The real-time database was the original database, the predecessor to Firestore. And you can compare them. I think there's a couple things that the real-time database might do better than Firestore, but the vast majority of things I prefer Firestore for. It is significantly easier to use than the real-time database. So I'm not even going to cover the real-time database unless a lot of people request it. But personally, if I'm building an app, it is Firestore automatically. So we're going to create a Firestore database. And then we're going to start adding to it in the next couple of videos because there's a ton of stuff that we can do in the database. And I want to go through it all and try to answer a lot of the questions that you guys have. So in this video, we're going to make a fake database just using the web browser here. We're actually not going to write any code. We're going to get coding in the next video. So again, Firebase has phenomenal documentation and videos explaining how these things work. I highly recommend watching this one, Introducing Firestore. You can also go to the docs and go to build and go to Firestore. And pretty much all the tabs are going to have videos. The guy that does these videos does an excellent job at explaining it all. I'm going to go through and actually start building, but I highly recommend watching those on your own time. Let's create the database. All right. When you create a database in Firebase, you're allowed to add security rules to the database. This is basically extra rules for who can access this database, right? Because the database is on a server. So technically anyone with a link to the server could access it, right? That could leave you open to hackers, bad users. Someone else could build an app and then connect to your server. So these security rules allow us to be extra safe and ensure maybe only users who are authenticated can access our database. And even more than that, we can write rules for only certain users can access certain parts of the database. So, for example, if you have a user profile, you might only want to allow the current user to edit their own profile, right? You want to restrict other people, other users from editing another user's profile. So you could write a rule for that just in case. Now, obviously in your code, you would try to obviously avoid that and never write that, but we want to be extra safe. Like you could imagine that you wrote something wrong in your code. You don't want to cause mayhem in your database. So these security rules are an extra layer, and they're honestly here for us as the developer. They're annoying because we have to set up extra rules and do extra work, but in the long run, it's definitely worth it. I'm going to do a whole video on how to write the rules later because the rules we actually cannot write in Swift. For right now, we're just going to leave our database open so that anyone can read and write to it. So we're going to start in test mode. And test mode is just a very simple rule that says anyone can read or write if it is the current time is less than 2023, February 20th, which is basically 1 month from right now when I'm creating the database. We can go in and change that later, but that's fine for now. So let's click next. And then it's going to ask us where we want to host our servers, basically. And so the main ones are in United States and Europe. Those are probably the best two to pick. The regional ones, I guess, are smaller maybe. So when a user opens your app and the app has to ping the server, this is saying, where is that server going to be? So it's not necessarily where you're sitting. It is where the majority, most of your users are sitting. Because if a user is in New York and the server is in New York, that's going to be a lot faster than if a user is in New York and the server is in Tokyo, right? It's still going to work, but that ping is going to be slightly slower because it's going across the world. So here you want to kind of basically pick where the bulk of your users are going to be. And you cannot change this later. So it's pretty important where you're going to pick. I'm doing United States. Let's click enable. And we have our database. I absolutely love it because we literally have a whole database here already. And it took nothing to configure, right? Like in CloudKit, I did a series in CloudKit on my channel. It works, but it's annoying to set up because you have to create your developer account. You got to log into their platform. It just seems like a lot more heavy lifting than this. This is our database. This is the whole console right here. And you could think of the Cloud Firestore database basically as it's very similar to the file system on your computer. There are folders, and inside each folder are documents. The only difference is the folder is called a collection here, and the documents inside a collection they don't have to be, but should always be the same document type. So for example, if I have a collection of users, every document in that collection should be a user profile. And the reason is because when we do a query or we do a fetch request to that collection, we don't want to guess what kind of data is in there. We want to know as a developer, all of the user profiles are in that collection. Very simple like that. If we look at the Firestore documentation, let's see, it tells us flexibility, querying. So we can run queries on it. So get all users who are premium, something like that. We can listen to it in real time. So if we have like a chat app and we want to get those messages as users are messaging each other, we can get real time. It has offline support, although we're not going to incorporate that in this course. Basically, it's a toggle that allows you to cache data on the device. And designed to scale. This is so incredibly important. I feel like a lot of people always say that Firebase can't scale. I have personally seen it scale to literally millions of users. These databases are built to scale. We do have to think about how we set up our database so that it scales as efficiently as possible, but they are designed to scale. So for example, if I create a collection and I add documents to that collection, I can actually add an unlimited amount of documents to that collection. So think of it as like a folder with an infinite amount of documents in it. There's literally no hard limit on the number of documents in a collection. However, there are some limits on the database, of course, and we're going to go read through some of the docs as we get into it. But I would recommend watching their videos on how to structure your data, how to create arrays and maps, and we're going to dive into some of that right now. Where are the limits, though? I want to get to the limits. Let's Google Firestore limits. And yeah, so We do get, so we're on the free quota. So we get 50,000 document reads per day, 20,000 writes per day, which is a lot, right? If you're just starting out your project, probably not going to have 50,000 reads per day unless you're actually growing, at which point you're going to upgrade your plan anyway, because you got to start paying for some stuff. But we're not going to hit that as we develop our app right now. There are some limits, which you guys can read through as well, on how to create your documents. The limits are large. I have not hit any limit ever while creating these. I think I want to say 1,000,000 bytes. Yeah, a maximum size for document is 1,000,000 bytes. So you could think a byte is essentially close to like 1 character. So 1,000,000 characters in a single document. So if you think of like your user data model and you extracted all of the title, book, author, name, email into bytes, you would need 1,000,000 characters in that document to hit this limit. And so if you get to something like that, you can always just create 2 documents and somehow link them together. But I've never hit this. I doubt you will as well. There are limits on writes and transactions. If people are pinging your server at once, it will start to slow down. But these are all basically things that you don't have to worry about when you're just starting your app. If you're successful and you have hundreds of thousands of users, it might be worth going through some of these in a closer detail. All right, so let's go in and actually start kind of playing with this. And again, we're not going to write code right now. We're just going to play around with it. So let's create our first collection ever. And we're going to call this fruits. So it's going to be collection of fruits. All right. Inside the collection is going to be a bunch of documents of each fruit. Now I can add in my own document ID. So if I want to add maybe the ID of apple for the apple fruit, I can do that. Generally, when you're creating a document ID, you want to use some sort of unique identifier because you can't have 2 documents with the same ID. So if I try to create apple and then I create another one apple, they're going to basically overwrite each other. So we want unique IDs. And here I'm going to use an auto ID. So within this document are going to be a bunch of fields. Think of this as your data model, right? So your data model is going to have name, title, email, all that kind of stuff. So each fruit is going to have a bunch of fields. It's going to have name for the name of the fruit. So we'll add in apple here. What else? Maybe it's some sort of health related app, right? And we have nutrition facts. And so maybe we have like sugars, how many sugars are in it? And we could add in all these different types here. We can add in, so maybe sugars is like 30 grams or something like that. What else can we do here? We can do Booleans. So maybe we have like a is healthy type Boolean. Now, when we create fields in the database, we have to think about how we want to actually structure the keys. Keys generally should be strings. And in Swift, when we write code, we always do camel case, which is very convenient. But when we think about these databases here, like a remote database like this, our Android app, our web app, if we have other apps for this product, they're all going to connect into this. So all of those developers need to be in sync on how we are naming the things in our database. And what I have found is the most common approach, the most universal approach is to do lowercase snake case. And that is my recommendation to you guys. So instead of a camel case like in Swift, we would do a is_healthy, which is a lowercase snake case. Now we're going to get into this when we actually start writing the code for it. If we are doing this, the normal Swift decoders, when we conform to codable and we have encodable and decodable, the normal decoder is not going to understand this lowercase snake case. So we're going to have to specifically tell it we're using lowercase, whereas the default in Swift would be is healthy like that. So I'm going to do it like this, and we'll set the Boolean for apples are healthy, and let's set it to true. I'm not going to do all of these, but we can do a map. A map is basically like a JSON object. So we could put almost like a child data model inside this file. So we can do an array. So we have a bunch of strings, a bunch of integers, something like that. Null is just nil value. Timestamp. So oftentimes when you create a document, you should add in a date created field. Not that you need it in your app, but it's good to have, just so that we have a reference of when it was created in case we ever want to use that again or something like that. And so I'll put the date created as right now. Awesome. And sometimes people also have like a date modified. So if someone is editing a profile, you keep track of when was the last time it was modified. or if you have some sort of ranking system where you want to put the most recent items up front. So the modified date would be like how you track that. We can also do geopoints. A geopoint is a latitude and longitude. So if you have an app where the user has their current location and you're trying to show other users how far they are from this user, you would upload their latitude and longitude to the database. And then on the device, you would say, how far is the current user from that latitude, longitude? Obviously, we don't need that for our fruits. Let's click save. And we have our first collection. So our fruit collection with a bunch of documents and fields. Oh, I forgot. I highly recommend that you do is inside each collection, I like to create another field called ID and paste in that ID again. And the reason I do this is because when you decode in Swift, when we use the decoders in Swift, we do not get access to the actual document ID. Now we can write extra code to get the document ID, but I would rather just a simple function to decode this document in one quick go. And when we have data models in Swift UI, especially, oftentimes we want to conform to identifiable. And so now we will have the ID at all times in all the data, in all the documents, and the ID should match the document ID. You don't have to do that. It's a personal preference. I highly recommend doing that, but now you know. Let's add another document, and we're going to want to do the same fields that we have here. So is healthy, name, sugars. All right, let's make this name. Let's say orange. Let's say is healthy, a bool. I know oranges are healthy, but we're just going to put false. Let's put sugars. I have no idea how much sugar is in here. And let's make this a number. Let's also do maybe 25, and let's save it. Now we can see the two different documents here that have different pieces of data. They're both fruits, but they have different amounts of data. So this is also something that is important when we are querying, right? So we want to ensure that when we are decoding our objects, we are keeping track of like what values are optional, which ones are not. So for example, if date created was a required field, and then we try to get all of the fruits, it would fail because this doesn't decode because there's no date created in here. The cool thing about the database here is that we can literally change these manually, and this is like a very easy flow to understand, right? So here I can change this to true, update, and it updates in real time. If the app was listening to this, it would get that ping in real time. If an app was doing a fetch request right now, it would get the ping right now at real time. So at a high level, this is kind of how it works. You create a collection and then you have documents. So in your database, you're going to have a bunch of high level collections. Another collection you probably will have is users. Most databases have a users collection. This is like your user profiles. And so right now, let's just create a fake user, which is like a name with just like an ID. And let's put in the document ID as their ID. So we're going to write code for this later. But basically, after a user authenticates into your app and you have their authenticated ID, you're going to take that authenticated ID, go to the Firebase database, create a user collection, and make that their document ID. And then you'll add in the ID with their document ID and click save. So you do that, and we're going to do that in code in probably the next video. But so now we'll easily be able to know if a user has a profile because their document ID is going to be their user ID, which is their authenticated user ID. And that does not change because the authenticated ID is stable, which is basically why we authenticated them. So the correct approach is authenticate your user, get their user ID, create their document in the database, and then let them start updating their user profile. So maybe you have some UI that says add your name, and they'll add in their name and they'll start filling out their user profile. Now let's pretend for a second like I had an app where we had users were adding fruits to their grocery list. Okay. So the question becomes, where should we put that grocery list? And there's a bunch of places that we can do it. We're going to walk through 3 different ways to add that grocery list right now. So firstly, let's think about this grocery list. This grocery list, we don't want to put it inside the fruit document because the fruit document is going to be accessible to everyone across our application, right? And so if Nick has a list of fruits, some other person using our app does not need to ever see that, right? And if we had Nick's grocery list inside this fruit document, when some random other person downloads this fruit document, they're going to get my grocery list. And if they then update the grocery list and it updates this document, it's just going to like overwrite my stuff. So it's obviously not the right place to put it. So where can we put our collection of grocery lists? And now let's think about different ways that we can actually add this grocery list, right? The grocery list is obviously coupled to the user. So maybe we can add it into the user profile. So every time the user opens the app, we're probably going to download their user profile. Maybe we'll also download their grocery list. So we can add a field here, and we can call it maybe grocery list. And how would we want to keep that grocery list in our app? How do we want to store it? Well, we could store it as a map, which would have like basically keys and values, kind of like a dictionary, or we could store it as an array. Let's do an array for now. So maybe the grocery list, an array of strings. And the question is, how are you going to store the data in the grocery list? Well, we can store the word apple, and maybe we'll do another one with the word orange and click add. So this would work. And in our user model, we would have a field called name of type string and a field called grocery list of type array of string, right? And this would work. But a couple of things to note here. Firstly, this makes sense to us as a regular human, Apple. But in our app, we're going to want to be able to get the actual fruit document for this item in the grocery list. So if I go back to the fruits and I look at the apple document here, there's already a difference, right? This is capital A, apple, and the one in my grocery list is lowercase a, apple. So it could work, right? Maybe we are being case sensitive in our app, or maybe not. So we have a way to map which one is an apple or which one is not. So if you had it set up like this, you would have to run a query on your fruit. So you would say, fetch the fruit where the name is equal to apple. And that's definitely doable. But there's actually a better way to write this, and that's by using these IDs, which is incredibly important. So we know apple here always is going to have this ID, right? Even if we change the name. And that's also important because imagine one day we change this to Granny Smith apples. The ID is going to stay the same, but the name of it might change. So then our query would fail because the name changed. So oftentimes when we are tracking things in our app and we're tracking something in another document, we actually want to reference the ID of it. So I'm going to come back here, and in my users, this should really be the ID of it. And the orange should also be the ID, which we did not add, which we should have added. I'm just going to add in the ID here. And so here, the orange should look like this. Now, obviously this looks worse to the human eye because we don't know what the hell this is, but the app will know, okay, now all we need to do is fetch the fruit with this ID. So we don't even need to run a query on this collection. We can literally just say, go to this collection, go to this document, return us the data. So that's already a step better than what we had before. But now we have more questions to think about. So right now we have this grocery list in our app, but it's limited to just an array of string and an array of string. What if we had a grocery list where we wanted users to be able to maybe create a priority for each of the items on their list, right? Or a completed state. It's like maybe they're going to be going shopping and they'll say, is in bag, check. And so like while they're using the app, we change a Boolean on the grocery list of whether or not it's a high priority or whether or not it's already in their cart kind of thing. Well, if we have this simple array, we can't actually add any extra data to each of these, right? It's just an array of strings. So for simple data like this, this would work. So an array might be good for if a user has maybe an array of favorites and all it is just an array of IDs. Or maybe a user has like, I don't know, 3 preferences set and you just want to store them in a quick little array. This would work. But if we're going to scale this to add in extra data, this doesn't work perfectly. And so what can we do instead? Well, there's 2 other options, basically. So in the same way that we have collections here, these are top level collections, right? So we have a collection of fruits with a bunch of documents in it, collection of users, a bunch of users in it. We can also create collections within each document. So here we have a collection of users with a user document, and then we can create a collection within that user's document. So this would then be a collection that is basically specific to this user. So I'm going to create a collection here and call this grocery list. So this is my collection called grocery list. And the grocery list is going to be a collection of a bunch of documents that the user has in their grocery list. I'm going to create an auto ID here. Let's pass in an ID field of auto ID. Let's create, and then let's call this maybe fruit ID. Pass in, and we'll pass in the fruit ID, which I don't have right now. So I'm just going to put A for a second. All right. So the fruit IDs are here. I'm just going to copy that from the apple and the orange. And we can see that the user has a document, and then that document has a collection. And it looks literally just like our last collection. There's a bunch of documents in here. And I'm going to update the fruit ID to this. I'm going to also copy this fruit ID, come back in here, and add another document. Let's call this ID, and then fruit ID. Pass in the IDs here and save. All right, so now instead of this grocery list, this array that we had, we have an actual entire collection of documents, each of which are an item on the grocery list. And the benefit now is that we can also add more data to these documents. So we have the fruit ID, but maybe we can also say like priority. And the user is going to determine if it's a high priority item or something. Or maybe this one is a priority of low. Something like that. So now this is giving us the ability to add a lot more data to each of these documents. Couple things to point out here. I added a unique ID for these documents, and then I added the fruit ID in here. We alternatively could have just made these documents with the fruit ID and not needed to manage two IDs here. That's a decision that you have to make as the developer. And the difference between those two is basically that the IDs you can never have two documents with the same ID. So if your grocery list is only ever going to have one apple, so we know like the ID for apple is this, I think it's this one. If there's ever going to be, one apple on your grocery list or one item with that ID, then we can use it as the ID here. But if maybe a user is able to add the item multiple times to their grocery list, then maybe we want a unique ID so that we could add the same fruit ID to multiple documents and have those documents have different document ID. Alternatively, we can also, in the field, we can just say like account with an integer of 5, right? So maybe if a user's adding 5 apples, we could add 5 documents, or maybe we could just have one document with a count of 5. You got to figure out the best way to approach it in your application. The important thing to figure out is basically how you're going to fetch the data. We're going to get into this in a future video as well. So basically when you do a fetch request, you're either fetching one document or you're fetching from one collection. Okay, so in my app right now, the fruits collection is a collection. And so I can do a query that says get all documents inside the fruits. And that's going to give us all of the documents. That's perfect. I could also say get all documents inside the fruits collection that are healthy. That is healthy is equal to true. And it will run the query on all of the documents. That is perfect. I can go to my users and I can say, get the user with this ID, get their document. Now, when I get the document for this user, it's not going to get the sub collection. It's only going to get the document for the user. So in our first attempt, if we had the grocery list inside the user document here, I could fetch both of this, all of this together in one request, right? And that's important because when you get to large applications, you want to limit the amount of requests you're going to do, or you want to be as efficient as possible. So if it is something that you can keep simple like this is probably better because we just fetch the user. We're probably going to do that every time the user opens the app, and we'll already have that data. But if we are using this approach, we're going to have to fetch the user document. And then separately, when we want the grocery list, we're going to say, go to this collection and fetch the grocery list. So it's an extra fetch, but it also is opening us up to extra queries. So here, if we're trying to get this grocery list, we can't really query on it. There's nothing to query on. What are we going to say? Get all fruit IDs, get all high priority fruits. We can't query on anything here. But since we have a collection, we can say, go to this collection and then give me all of the fruits that are low priority. So it gives us a little more room to play around. I would probably recommend this approach more than this approach for most things, but maybe not everything. And now the question becomes like, what if maybe we want to allow them to have multiple grocery lists, right? So this collection is for one list of groceries. We could add another collection that says grocery list 2. That's not very scalable, right? Every time we're going to add grocery list 3, grocery list 4. So what we could do is instead of this, we could have a grocery lists with an S, click next. Each list will have maybe a document ID, and let's add in that ID. And then maybe each list, the user gets to name the list, right? So maybe my first list is going to be this one. So now we have a collection of lists, and then each list will then have a collection of items on the list. So here we're going to maybe fruits, we can call it products. I'll call it products for now, or let's just say items, maybe all the items on the list. And then we will save auto ID. Let's pass in our ID, and let's pass in the fruit ID, which I don't have. I'll just click save. All right, so where are we? Our original grocery list had documents with auto-generated IDs, and then we passed in a fruit ID as well as a priority, but this was limiting us to one grocery list per person. Now we're going to have a collection of grocery lists. Each will have a unique ID, each list. And so this allows us now, each list can have its own data as well. So the list can have its own title here. We can give it, maybe each list has a color scheme or something. We can add in data. And then when we want to get the items for that list, we go into the items collection of that list. And then this document is the same as the document on our first list, right? So if I go back here, the grocery list documents, these documents with the priority and fruit ID are going to be the same as these next level documents where we have fruit ID and priority. All right, so now we opened ourselves up for the ability to add multiple lists to our application. One final way that we could do this is basically this same approach here. So we have grocery lists and then a bunch of grocery lists. This collection of grocery lists is a child collection of the user profile. Alternatively, we could have made a top level collection. Could have called it grocery lists, right? And maybe each grocery list, again, will have an auto-generated ID. And let's give it a name. So we'll say my first grocery list and click save, right? And then let's get that fruit ID. So grocery lists will have a document with the name, maybe some other data. And then the grocery list will have a collection, again, of items. And each item is going to have auto-generated ID with a fruit ID, as well as the document ID. And save. And then again, we can start doing our priority, and we can do low here. But so now the question becomes, if these grocery lists are not underneath each user profile, how are we going to know which ones are for which user, right? And so what you would do in this case is then inside the grocery list, you would have some sort of like user ID or maybe author ID or created by. I'm going to do author ID, and we're going to put in a user ID there. So our user is this value here. I'm going to go to the grocery lists, and the author ID will be here. So now I could have this user profile, pretend like this is not here, pretend like these are not here. I would have just a user profile with this ID. And when they go to their screen that says, here's all your grocery lists, I would run a query on this collection that says, give me all of the documents in the global grocery lists collection where the author ID is the user ID. So now we would put all of the users' grocery lists into this collection, And then we just query on the author ID. And the benefit this would open us up to is if this was something that was like shared among multiple users, right? And many users were accessing maybe the same documents. So if it's your personal grocery list, maybe you put it underneath the user profile. But what if it's like a shared grocery list? Or what if it's like not a personal grocery list? It's something that is like shared content across your application, like a chat maybe, right? Because in a chat, two different users are going to be accessing that. So you would have a collection here of chats with the user IDs inside, and then query on which chats is the current user in. So this is kind of the third approach here. This is kind of a high level of how you need to set up your database. Any of these approaches work and they are best for different things. It really depends on how you're going to fetch the data. So I would personally, if you've never done this before, play around with this before you actually write code. I would make collections and try to figure out where my queries are going to go. How am I going to access all of this data, and then start writing code to do this? High level though, collections are highly scalable. Even if I have this shared grocery lists and everyone in my app and have 1 million users putting their documents into this grocery list, I can put unlimited documents into a collection. So I don't have to worry about scale. I do have to worry about that 1 million character count inside each document. But if I'm breaking down my data the way that we're doing it here, I'm not really going to have to ever worry about that because each of these documents are relatively small. This is, a couple pieces of data. I might have a couple hundred pieces of data, but to get to 1 million character count, you probably need to put a lot of stuff into that document. Like if you didn't create a full database and create all these collections and you just stored everything ever into one user document, maybe you eventually reach it. But if you're setting up your database the right way, you'll probably never hit any of those limits. So again, this is super scalable, very easy to use. And in the next couple of videos, we're basically going to set up kind of what we just did here, except with actual data in our application and do it from our app rather than actually clicking buttons here. So before we end this video, I'm going to actually delete everything that we did in this video so that we start with a fresh, clean database for the next video. So one thing that I will point out as we do this is, so here I can delete the document, this user document, I'm going to delete. All right, so let's clear everything out. One thing to note though is that as we delete it in the console, this deletes data at this location and also all nested data. So we delete the child collections as well. When we are running, so I'm going to delete these entire collections. Just delete the collection here, delete this collection, and delete this collection. All right. And we're back to our starting database, literally nothing in it, clean slate, ready for the next video when we actually start writing code. Hopefully this was a good intro though to what we're going to do, because I feel like when we work with databases, a lot of times it's like, what's really happening? And I wanted to cover like a high level first, because like for me at least, seeing this play out and being able to like add and change things on my own is much easier than writing code. And then later when I write code, it's much easier to understand exactly what I'm writing. All right. I hope you guys feel the same way. If you do, leave a comment. Let me know if you do. But anyway, if not, I probably just wasted some time in this video, I guess. But anyway, we now understand Cloud Firestore, at least at a high level, and let's write some code. So hope you guys are excited, because I am excited, and we're going to write a lot of code in the next video. Thank you guys for watching. As always, I'm Nick. This is Swiftful Thinking, and I'll see you in the next video.